NASA's deep space cameras have captured what no one ever expected to see inside an interstellar object: movement. Something inside 3I/ATLAS.
NASA's cameras have captured something strange inside 3I Atlas, and experts are uneasy. Subtle, almost imperceptible movements hint at forces no one expected. This interstellar visitor, crossing silently from another star, seems almost aware. Each new image deepens the mystery, sending chills through scientists who study it. Whatever lies within, it is unlike anything humanity has ever encountered, and no one can predict what it might do next. The impossible movement. On July 1st, 2025, something unusual was observed by the Atlas Survey Telescope in Chile. The object was named 3I Atlas, also known as C2025N1. Scientists immediately realized this was not an ordinary space rock. It was the third confirmed interstellar visitor humanity had ever seen. Only Oumuamua and 2I Borisov had passed through before it. Now, a new traveler from another star system was here, and it carried mysteries that no one was prepared for. Its orbit revealed the first surprise. It followed a hyperbolic path, which meant it was not tied to our sun. It would come in, perform a brief cosmic visit, and then leave forever. Hubble took early measurements and found that the object could be as small as 440 meters or as large as 5.6 kilometers wide. Even this wide range added to the mystery, because such objects are usually easier to size. NASA also reported that 3I Atlas was moving at an extremely high speed, both inbound and outbound, which matched the behavior of an interstellar object but still felt unusually sharp and precise. As it moved deeper into the solar system, telescopes captured something that changed the entire story. A glowing coma began to form around it. This cloud of gas and dust meant that the object was active. It was not dead and frozen like many pieces of interstellar debris. It was behaving like a living comet. Hubble, Webb, TESS, MAVEN, MRO, and many more observatories turned their attention toward it. Scientists watched closely as the brightness of 3I Atlas grew rapidly. Some said the brightening was much steeper than what is normally seen in comets. This early behavior made researchers pause. Something about this object was pushing beyond the rules they expected. When scientists examined older images from the Zwicky Transient Facility, they found another surprise. 3I Atlas had been active even at 6.5 astronomical units from the Sun, which is extremely far for such strong activity. Dust production rates were calculated at about 5 kilograms per second at that distance, and rising to nearly 30 kilograms per second at around 4 astronomical units. The brightening followed a pattern that was much steeper than usual, which forced scientists to wonder if something deeper was happening inside the object. Some observers immediately began whispering alternative ideas. What if this was not a normal comet at all? What if something inside it was powering these strange reactions? NASA continues to lean toward natural explanations, yet the unusual behavior refuses to settle into anything ordinary. The more data arrives, the more 3I Atlas begins to look like an object with an inner purpose, and its secrets are only beginning to surface. The internal shift. On October 2nd, 2025, the Mars Reconnaissance Orbiter passed within reach of a rare opportunity. The spacecraft turned its powerful high-rise camera towards the interstellar visitor. At that moment, 3I Atlas drifted only about 30 million kilometers from the orbiter. In the scale of space, that distance felt almost close enough to touch. The image that arrived at NASA showed a detailed look at the glowing intruder. It provided clues about the size and shape of the nucleus hidden inside the cloud of dust. Even with the thick coma around it, scientists could see a structure they had never observed in an interstellar comet before. Another Mars-based mission soon added even more information. The MAVEN spacecraft began a 10-day investigation using its imaging ultraviolet spectrograph. It watched the object in ultraviolet wavelengths that reveal the fingerprints of hidden particles. MAVEN detected a clear stream of hydrogen emissions through Lyman alpha lines. These emissions showed that 3I Atlas was shedding volatile material in large amounts. The ratio of deuterium to hydrogen within that stream may become one of the most important clues to the object's birthplace. Different star systems produce different ratios. Scientists hope this measurement will eventually reveal what kind of world created this wanderer. As the ultraviolet data continued to stream in, telescopes on Earth added their own piece of the puzzle. The SOAR telescope studied the brightness of the comet over time. It looked for any regular chances in light that would indicate rotation. Surprisingly, it found no strong periodic pattern. There were brief brightening events, but nothing that showed a steady spin. This uncertainty suggested that the nucleus might not be a simple shape. It might be tumbling. It might be uneven. It might even contain compartments that react differently to sunlight. These clues pushed researchers to a new idea. Perhaps the odd behavior of 3I Atlas did not come from its surface at all. Perhaps it came from deep inside. Heat traveling through an interstellar body could create strong thermal gradients. Pockets of trapped gas could burst into the coma. Ancient ices could crystallize in sudden waves of energy release. If these events come from internal layers, then the comet is not merely active. It is responding. It is shifting from within. Each new image and measurement seems to whisper the same message. Something inside 3I Atlas is stirring, and the surface is only beginning to show the truth hiding underneath. Signs of a shell. From the moment scientists plotted the path of 3I Atlas, they knew they were dealing with something that did not belong to our solar system. NASA confirmed that the object behaved exactly like an interstellar body. It moved too fast and flew too freely to have been born anywhere near our own planetary family. To go deeper into the mystery, another team, led by Perez Couto, traced the journey of 3I Atlas backward through the galaxy. They used data from the Gaia DR 3-star catalogue, which contains detailed information about the motion of stars near us. Their goal was to see if the object had a clear origin or if it had passed close to any known stars in the last 10 million years. Surprisingly, they found no convincing encounter. None of the stars it crossed paths with had given it a meaningful push. This suggested that 3I Atlas was drifting quietly through the Milky Way for ages. Its motion matched the behavior of objects in the thin disk of the galaxy, which means it may have formed in an ordinary region rather than a rare or exotic one. Yet the surface behavior of the object hints at something far from ordinary. Some researchers have suggested that it might contain layered structures. These layers could act like a shell with inner cavities or crystalline pockets that store energy and release it in bursts. Such a structure could explain rhythmic brightening and unusual pulses. A few amateur observers even claim that the object shows faint magnetic patterns, although there is no official confirmation of this. If 3I Atlas contains a shell, then it is rewriting our understanding of interstellar bodies. A natural shell would still be breathtaking. An artificial one would change everything. And somewhere inside that layered body, something may already be waking. The vessel hypothesis. One of the most well-known voices exploring 3I Atlas is Harvard astrophysicist Avi Loeb. He suggested in a thought exercise that some of the dynamics of 3I Atlas could match the movement of an artificial or technological object. His comments appeared in public discussions and news reports, and they sparked debate around the world. Most astronomers still believe that natural explanations are more likely. They warn that it is too early to jump to dramatic conclusions. Even so, the unusual behavior continues to fuel the idea that something deeper might be hidden inside this wandering body. If 3I Atlas were a vessel, what purpose could it serve? One theory imagines it as an information carrier. In this model, it might hold a crystalline or molecular library that preserves messages from a distant civilization. Such a structure could survive for millions of years as it drifts between stars. Another possibility is a seed probe. This type of object would carry biological or chemical seeds that could be released when conditions are right. Some scientists imagine this as a method for spreading ingredients of life across the galaxy. A third idea describes 3I Atlas as a deep space probe that remains dormant until certain triggers awaken it. These triggers might include heat from a nearby star, magnetic fields, or contact with solar wind particles. Speculation in the public has added more dramatic ideas. Some observers believe the object shows rhythmic light pulses that resemble signals. Others point to brief glows or tiny jets emerging from within the coma. These claims remain unproven, and no peer-reviewed studies have confirmed any of these signs. Still, they add an unsettling sense of possibility. There are strong challenges to the vessel hypothesis. Many features of 3I Atlas can be explained by known cometary behavior. Natural outgassing can create acceleration. Brightening can be caused by volatile ices. Ultraviolet readings showing hydrogen emissions match what is expected from a highly active comet. Scientists also remind the public that there is no confirmed evidence of artificial design. There is no radio beacon. There are no repeating coded signals. No structure has been imaged that resembles engineered material. For now, the idea remains in the realm of speculation. Extraordinary claims need extraordinary evidence. Yet even with these warnings, the questions persist. The strange behavior of 3I Atlas refuses to settle into simple patterns. The possibility that it contains hidden systems is becoming harder to dismiss. And if it truly is a probe, then something inside it may already be rising from a long and ancient sleep. Then comes another surprising observation that connects it to another planet of the solar system, Jupiter's trigger. Dynamical simulations showed that Jupiter's gravity had a strong influence on the object, especially after it passed its closest point to the Sun. This was expected, since Jupiter is the most massive planet in our solar system and often alters the orbits of passing comets. However, the models also revealed something less ordinary. The motion of 3I Atlas did not match what gravity alone should produce. There were hints of additional forces acting on the object. These non-gravitational accelerations were not fully understood, and they left researchers with unanswered questions about what exactly was affecting its path. This uncertainty led scientists to examine not only Jupiter's gravity, but also its environment. Jupiter has a very powerful magnetic field and a large plasma region filled with charged particles. As 3I Atlas passed through this area, the possibility arose that the object reacted to more than gravity. If its internal materials were sensitive to magnetic fields or charged particles, they could have been affected by Jupiter's environment. Such interactions are known in physics. Magnetic fields can create electric currents. Plasma can energize materials. If the object had any conductive zones inside, these external conditions might have triggered internal activity. At the same time, the Sun provided its own influence. As 3I Atlas moved closer to the Sun, its surface and interior heated up. Comets contain volatile ices that turn into gas when they warm. If the object had uneven layers or deep pockets of frozen material, the heating could produce delayed or uneven outgassing. These sudden releases of gas could alter brightness or even slightly change the object's direction. This would match some of the recorded behavior. Observatories reported rapid brightening near perihelion. The increase in brightness was faster than what is normally seen in typical comets. This raised the possibility that the object was reacting to heat in a more complex way than usual. Another observation added to the discussion. Several reports described a change in the object's color. While many comets appear reddish or dusty, some images of 3I Atlas showed a bluish glow. This is uncommon and created debate among scientists. A color shift can come from gas emissions or chemical reactions occurring on the surface, but the bluish tone made some researchers wonder if something unique was happening inside the object during its travel through magnetic and solar environments. If 3I Atlas is responding directly to the conditions around it, then its behavior is not entirely passive. It may be undergoing activation processes that begin when it enters certain regions of the solar system. Whether these reactions are natural or require more complex explanations is still unclear. What is certain is that the changes in brightness, motion, and color suggest that external forces are influencing it in significant ways. As 3I Atlas continues its path toward the inner solar system, these triggers appear to be increasing. The object is showing signs that its internal activity is rising, and scientists are watching closely to see what will develop next. The adaptation phase. 3I Atlas was not moving exactly the way gravity predicted. In several community discussions and early scientific models, analysts observed small deviations in its trajectory. These deviations suggested non-gravitational acceleration. In other words, something besides gravity appeared to be influencing its motion. If the acceleration came from natural outgassing, the amount of gas required would be extremely large. Some analysts pointed out that the observed activity on the surface did not seem strong enough to produce this level of force. The numbers did not align well. This gap between the expected and the observed created space for speculation. Certain voices, especially in public discussions, suggested that the motion looked almost like controlled behavior. Some even compared it to engine-like activity. This idea is controversial and is not accepted by mainstream scientists, but it gained attention because the object's movement seemed too precise for a normal comet. Along with the unusual motion, scientists also considered the internal structure of 3I Atlas. One hypothesis suggests that the object might contain internal cavities or chambers. These cavities could behave in complex ways as the object heats up. Gas could shift from one section to another. Materials could collapse or expand. This kind of internal redistribution could influence the direction of gas release and change how the comet moves. If these processes happen repeatedly, they could mimic a form of internal regulation. The object would appear to react to temperature changes and external conditions by adjusting its internal systems. Another important clue came from the light it reflected. Many observers, including amateur astronomers, reported unusual polarization in the light coming from 3I Atlas. Some even described it as stronger than what they have seen in normal comets. Polarization can reveal details about the surface and internal structure of an object. High or unusual polarization often suggests layered surfaces, uneven textures, or internal reflective zones. These features could point to a more complex build than expected from a simple interstellar comet. As these pieces of evidence came together, a new idea began to form. Perhaps 3I Atlas is not acting like a passive object that simply melts when it gets close to the sun. Perhaps it is self-regulating. This does not require the object to be artificial. Complex natural structures can also regulate heat, pressure, and material flow. However, the combination of changing brightness, unusual acceleration, unexpected color shifts, and strong polarization created an impression that the object might be adapting to its surroundings. With each new observation, the evidence grows. 3I Atlas appears to be doing more than releasing gas. It seems to be adapting as it moves, and the idea that it might be guiding parts of its journey is becoming harder to ignore. The awakening. NASA and partner observatories continue to track 3I Atlas as it recedes from the Sun, offering an unprecedented opportunity to monitor an interstellar visitor in real time. Hubble, Webb, TESS, and SOHO provide continuous imaging and data, each telescope contributing a unique wavelength perspective to build a complete picture of the object's behavior. Mars-based platforms like MRO, MAVEN, and the Perseverance rover have supplied crucial vantage points, while Earth-based telescopes add multi-angle observations, allowing scientists to trace the comet's tail, coma, and changing brightness across vast distances. Even the Lucy spacecraft, though on a separate trajectory, has captured distant images of 3I Atlas, revealing subtle details in its elongated tail and faint surrounding cloud. Ultraviolet and spectroscopic data show the presence of hydrogen, but more detailed measurements, including the deuterium to hydrogen ratio, may help pinpoint its system of origin. Photometric studies and pre-discovery archival data indicate active sublimation and dust production, even while the object is far from the Sun. These behaviors suggest internal processes that are not typical for ordinary comets. Some researchers speculate that further study could uncover unusual isotopes or molecular signatures, markers that diverge sharply from what is found in our own solar system and could offer clues about alien environments. Physical monitoring reveals further mysteries. If the comet's internal activity is genuine, 3I Atlas might eventually stabilize, or it could continue pulsing, shedding material in unpredictable bursts. Observations focus on structural changes. Variations in shape, spin, or orientation could indicate internal reconfiguration, suggesting that something inside is not passive. The implications are as philosophical as they are scientific. Whether its behavior is natural or hints at something more engineered, 3I Atlas challenges our understanding of interstellar objects. Models of comet formation, dynamics of dust ejection, and even theories of interstellar engineering could be upended if the comet is found to actively self-adjust. Humanity may be witnessing not merely a visitor from another star, but a construct, organic, mechanical, or hybrid, capable of actions that defy conventional expectations. As 3I Atlas drifts beyond Jupiter, fading into the darkness of the outer solar system, one question lingers. Whatever lies inside it may no longer be dormant. In ways no comet has ever displayed, it could already be alive, silently preparing for a revelation that may forever alter our understanding of the cosmos. What do you think could be hiding inside 3I Atlas? Share your thoughts in the comments below.